it out in Word. Explain to me how you got that. Let's look at Ashlyn's work. Ashlyn, explain to the class.
The problem was -3 plus x equals 14. So I added 3 on both sides. And -3 plus 3 is 0, and 14 plus 3 is 17. So x equals 17, and I checked my answer by doing 13. Well, -3 plus 17, which equals 14, because since it's different signs, you have to subtract. And 17 minus 3 is 14, and since 17 has a greater absolute value, the answer is positive.
Very good.
The problem was 12 equals x divided by 5. So I multiplied 12 by 5 and I got 60. And then x equals 60, and I checked my answer by dividing 5 into 60, and I got 12.
Very good. Check his answer. I like that. Let's check his work. Good job. Drew now book away. Take out the binder. Good job. So those are one-step equations. I can solve two-step equations using inverse operations without a calculator with 75% accuracy. 15 seconds. So Louisiana Student Standard, who wants to read it for me? Cartier.
Students translate word problems into algebraic expressions and become proficient at solving equations of the form px plus q equals r, and p, open parentheses, x plus q, close parentheses, equals r, where p and q and r are specific rational numbers.
And the standard is 7EEB4A. Okay, so this is our prior knowledge. We've been going over math vocabulary. Why is it important to have math vocabulary? Rakaya?
Because we need math vocabulary, because if we have those words on the test and we might not know what it is, so it's easy for us to learn.
Very good. Ashlyn? Okay, equation. What is an equation?
An equation is two expressions separated with the equal sign.
Very good. Let's see. An equation is a statement of equality between two expressions. And properties of equality. Lynn.
It says that you must balance each side, like whatever you do to one side, you must do to the other.
Very good, Lynn. I like that. Good job. So we have a few more inverse operations. Because that's in our objective, right? Thomas.
It's when you do the opposite operation to diffuse like the main problem.
Yes.
The x.
Yes. I like that you use diffuse. We use undo, but diffuse is good. You're gonna do the opposite operation. Remember, you add to get 0. Give me an example of additive inverse. Ryan. We haven't heard from Ryan.
Let's say you have 15, let's say, can I use an example?
Mm-hmm.
Let's say over a holiday you gain 15 pounds of weight, and then you go to the gym and you do 15.
Very good. So how do you know their additive inverse?
Because once you subtract 15, you have 15 minus -15 equals 0.
Okay. 15 minus -15. 15 minus -15, write that down. Let's make sure we're saying it correct.
15 plus -15.
Very good. 15 plus -15 equals 0. So multiplicative inverse. Then, what are we doing with that number? We're not adding. So, Corey, what are we going to do? You there? Okay.
Like 5 times.
Write it down so you can see it, and then you can tell us. Okay, now not 5 times, because 5 times 5 doesn't equal 1, but I like the idea.
5 times negative 5.
Write down 5 times negative 5. Okay, I like the fact that you know you're trying to get to 1. But if you don't know how to get to 1, that's where we're going to have the problem in the class. So let's see, we have 5. How do we get to 1?
1/5.
Times 1/5. You see it? 5 times 1/5. Reciprocal. Very good. We're going to do the reciprocal. So the number you multiply to get 1. Okay, so let's go on. We're going to go flip in the classroom. 7th grade Common Core workbook, page 65. Read from the beginning through example 1. You have 5 minutes. So most people are finished. Michelle's writing some notes, but we're also going to get the notes as we go through the PowerPoint. So what did we learn from our reading? What is the main part of the lesson that you just read? Because our objective says I can solve two-step equations for the value of the variable by using inverse operations without a calculator with 75% accuracy. So what is the main part of the objective, Karina?
The main part of that,
The main part of your reading. I'm sorry, go ahead.
is you have to put the variables on one side and put the integers on the other.
Okay, but what did they tell you to do first? That's good. Variables on one side, integers on the other. Isaiah?
You have to use inverse operation.
Inverse operation of which one first? Yes. Addition and subtraction. You have to undo addition and subtraction first. That's the first step. What's the second step from your reading? Thomas?
To undo multiplication and division.
You undo multiplication and division. So here are the key points. Read it for me. Lynn, read the first bullet.
Get the variable x by itself on one side of the equal sign. Another way to say this is you need to isolate the variable.
Okay, and that's what Karina said from her reading. And then the next, Dejan, the next bullet.
Keep the two expressions equivalent to each other. Another way to say this is you need to keep the equation balanced.
Balance, and that is properties of equality. Okay, so I want you to write key points, and then I just want you to write what's in red. Isolate the variable and keep the equation balanced. The next slide. The goal is to rewrite the equation where x equals a number. But the main part, and this is how I like to remember it, we're making zeros and we're making ones. How do we make zeros? Rakaya? Additive inverse. How do we make ones? Lynn? Multiplicative inverse. Very good. So step 1 is to make zeros, and step 2 is to make ones. 0 comes before 1, so you remember as 0, then 1. Step 1, make zeros. Step 2, make ones. So let's look at a video.
Is 16 is equal to x over 4 plus 2, and we need to solve for x. So we really just need to isolate the x variable on one
Good
side
job.
of this equation. And the best way to do that is first to isolate this whole x over 4 term from all of the other terms. So in order to do that, let's get rid of this 2. And the best way to get rid of that 2 is to subtract it. But if we want to subtract it from the right-hand side, we also have to subtract it from the left-hand side, because this is an equation. If this is equal to that, anything we do to that, we also have to do this. So let's subtract 2 from both sides. So you subtract 2 from the right, subtract 2 from the left, and we get, on the left-hand side, negative 16 minus 2 is negative 18, and then that is equal to x over 4, and then we have positive 2 minus 2, which is just going to be 0, so we don't even have to write that. I
So
could
that's
write
why
just
we
a
make
plus
all 0.
but I think that's a little unnecessary. And so we have negative 18 is equal to x over 4, and our whole goal here is to isolate the x, to solve for the x. And the best way we could do that, if we have x over 4 here, if we multiply that by 4, we're just going to have an x. So we can multiply that by 4, but once again, this is an equation. Anything you do to the right-hand side, you have to do to the left-hand side, and vice versa. So if we multiply the right-hand side by 4, we also have to multiply the left-hand side by 4.
Okay, so the first thing he did was to subtract 2 from both sides. Why did he do that? Why did he subtract 2 from both sides? Andy? Properties of equality is why he did it on both sides. But why 2? Why did he subtract 2? Give him some think time. Why do you think he subtracted 2? Okay, Lillian, can you help him out?
Because anything you do to one side, you have to do to the other.
Okay, that, but why the number 2? Why did he subtract 2? Karina.
So it could be 0.
Very good. Remember, we're making zeros and ones. So he subtracted 2 so that we can make 0 right here. He subtracted 2 to make 0, and like you all said, he did it on both sides because it's an equation has to stay balanced. If I subtract 2 from one side and not the other side, they're not equal, right? Think about a balance. Okay, so why did he multiply 4 to both sides? Why did he multiply 4, Thomas?
To get 1.
To get 1. So we're making zeros and ones. So just what I said is what was taught, right? Okay, let's go on to the next part. So this is a 2-step equation. This is my example. I do. So write down the equation. 2n plus 57 equals 137. My next step would be to subtract 57 from both sides. Okay? So I'm subtracting 57 from both sides because I'm trying to make 0. When I subtract 57 from both sides, it's the additive inverse. So write down the next step. I'm making 0. So now I have 2n plus 0 because 57 plus negative 57 is 0 equals 8. Who doesn't see that? And I put plus negative 657 because it is the additive inverse. Now, when I add 2n plus 0, what do I get? 2n. And I call that the identity property of addition. So now I have 2n equals 80. So now I need to make a 1. I made my 0, now I need to make a 1. 2n times 1/2, or 2n divided by 2, will give me 1. Multiplicative inverse. And what I do to one side, I do to the other side to keep the equation balanced. So, 1 times n, identity property of multiplication is n equals 40. So I am explaining why I have the answers I have at each step. And so the answer is n equals 40. So the first step is to make 0. The second step is to make 1. Okay, 15 seconds. From the Ready Teacher Toolbox. Page 164, number 5, and we're going to do the we do. 2/5 x minus 1 equals 9. Complete each step. What do I have to do in this first step, Dejan?
Add on both sides.
What am I adding?
You're adding 1.
Adding 1. Why am I adding 1? Karina?
To make it 0.
To make it 0. So 9 plus 2/5 x minus 1 plus 1 equals 9 plus 1. 9 plus 1 equals 10. So now, what do I do with the next step? Lillian?
You have to try and get 1.
Try and get 1. So how do I get 1, Adrian?
By doing 25
2/5.
2/5 times the reciprocal.
The reciprocal. And what is the reciprocal of 2/5?
5.
Go ahead.
5 over 2.
5 over 2. Very good. And what I do to one side, I must do to the other side. So I have 10 times 5 over 2. Right?
Yeah.
So now this will equal 1x, which is x. And this is going to equal what?
50 over 2.
50 over 2 is
25.
25. Good job. Good job. What do I do to check it? Sabria, what do I do to check 25 to make sure it's correct?
You're gonna rewrite the problem.
Rewrite the problem, good job. 2/5 x minus 1 equals 9. And then what am I gonna do, Sabria?
You're gonna change the x into 25.
Very good. 2/5 times 25 minus 1 equals 9. And Sophie, what is my next step? Two-fifths times 25 minus 1 equals 9. What is the next step?
Multiply 2/5 times 25.
Right, multiply 2/5 times 25. I like to work with smaller numbers, so for me this is 5 and this is 1. So 2/1 times 5/1 minus 1 equals 9. 2 times 5 is 10 minus 1 equals 9. 9 equals 9, and it is correct. Okay, so we're gonna go into U-Do. Take out your whiteboards. We're gonna just work through it. You won't know until you work through it. All right, so we know partner A starts it off. You're gonna do question number 1. Partner B is writing on their paper. No one's talking right now. I'm setting the timer for 3 minutes so you can get a solution. Good job. I see some zeros. Good job. Equals 9, and then show me this. So put 3K equals 9. Just for Leaf, they're going to want to see it step by step. And then put that you either multiply both sides by 1/3 or you divided both sides by 3. I see your work here, but for Leaf, they're going to want to see you go all the way through it. Let's show you. So you have divided by 3 over here, right? But we have an equation. So whatever you do to one side, you need to do to the other side. So what's another way to show division without the division sign like this? What's another way? Yes, very good. Good job. All right, now the timer's up, so you all explain.
This is what I did. So it was 3K minus 2 equals 7. So I added 2 to get 0 on both sides. So 7 plus 2 equals 9, and 2 plus negative 2 plus 2 equals 0. That got me 3K minus 0 equals 9, but 3K minus 0 is just 3K. So it's 3K equals 9. So then I multiplied both sides by the reciprocal. So it's 1 over 3 times 3K, and that's 1K. And 9 times 1 over 3 is 9 over 3.
Okay, if you
1K equals.
stop. If you agree, I want you to initial. If you do not agree with your partner's work, I want you to circle the wrong step. Remember, we're trying to find, if there's a wrong step, it's okay. We're gonna find it. Yes.
And then after I get 1, I go on the other side so we keep balance.
What do you think the answer is, Karina?
K equals 3.
K equals 3. Who has K equals 3? Very good. Good job. So we're there. We have one group who's still struggling. Let's see if they can understand after Zakoya explains.
Problem was 3K take away 2 equals 7. First he had to get 0. So he added 2 by negative 2, and since he had to do the same thing to the 7, so he added 2 plus
Okay, speak up so we can hear you.
2 plus 7, which got him to 9, and
We made a 0. What's the next step we have to do?
find 1.
Make a 1. So how do you think he found 1?
I don't
Okay, Devon, go up and explain to her. Speak up.
After I got 9, 3K. So it was 3K equals 9 divided by 3. And to make one, I had to do 3K divided by 3.
Mm-hmm.
And that's where I got my 1K from.
Very good.
And
Yeah, final answer is
K equals 3.
K equals 3. Very good. Good job, guys. All right, so we're working on number 2. All right, 3 minutes. You're working solidly. Make 0 first. One way to think about it is put your finger over the term that has a variable, and then you know what you're dealing with. Don't, so you'll know which one to subtract or add. Put your finger over the term that has the x. Okay? Now remember to look for your signs. Don't throw your signs away. You have to know your integer rules. Does this make 0? Well, then you need to do the same thing over here. And then you need to follow the integer rules. The common mistake I'm seeing is that you're not remembering a negative plus a negative is a negative. Same signs add, different signs subtract. Same sign to what? Different.
Keep the larger.
Okay. So remember your integer rules. Looks good. You check your work. Okay, now you can talk with your partner.
So 4x minus equals.
I did. I added 2 to negative 2 to get 0. And I added 2 to 42 to get 44. Then it got 4x equals 44.
This is where you messed up. Right here.
Good job. Right there. Explain to her why. Now don't erase it. Just explain.
Because 2 plus negative 42 equals negative 4. Now don't erase it. So it will be negative 10.
Put it up there so we can see it. So you understand now where you went wrong? So where did you go wrong?
I added the
And why should you have subtracted? Very good. If the signs are different, you subtract. So do it again, and let's see if you come up with the right answer. Okay, so I'm going to pull 6, and then we'll go into the exit. And Andy is up. Yes. And so the answer is? Good job. Good job. Okay, 1 second. Speak up for me. X equals negative 10. Let's make that negative really show up, because it looks like a dot to me. X equals negative 10. How many of you have X equals negative 10? Looks good. You're supposed to raise your hand. That's yours. 100%. Good job. Okay, Andy. Explain.
So I added 2 because that's a subtraction sign. And I got negative 40. So I multiplied 4 over 1 by the reciprocal.
Okay.
And negative 40 over 1 times 1/4 equals, and cross cancel to get negative 10.
And the answer is?
X equals negative 10.
X equals negative 10. Good job, Andy. Good job. Did anyone check their work? Okay. Thomas, bring it up and show us where you checked your work. Because that's important, to check your work. Okay, tell us what you did to check your work.
Okay, you're supposed to rewrite the problem, So it will be 4x minus 2 equals negative 42. And then you substitute the x with negative 10. So it would be 4, open parentheses, negative 10, close parentheses, minus 2 equals negative 42. And then you multiply 4 times negative 10 and you get negative 40 minus 2 equals negative 42. And then you do LAO and then you get negative 40 plus negative 2 equals negative 42.
And so negative 42 equals negative 42. Good job. So we get to our objective. The objective was, Ryan, read it for me.
I can solve two-step equations for the value of the variable by using inverse operations without a calculator with 75% accuracy.